This is Dusty Jones here to talk about the origins of trigonometry. Trigonometry literally means triangular measure. The trigo part for triangular and the metra part for measurement. Trigonometry is really connected and got its origins in astronomy. And that was because there was a practical need to describe the motions of the stars and planets from the perspective of someone living on Earth. The idea of a celestial sphere or spheres actually prevailed at the time, where Earth was at the center, and the idea was that the planets moved around on a sphere somewhere above the Earth, or the stars maybe operated on different spheres, but those were all concentric with the Earth being the center. So the main idea they were trying to use trigonometry for was to describe the distance between two positions of a planet, let's say a planet M, between times 1 and 2, so M1 and M2. The geometric name for that line segment between M1 and M2 is a chord, and what early trigonometers were doing were measuring the length of a chord as a function of the angle with the Earth at the vertex of that angle. The Babylonians were the first to introduce degree measure and a spherical coordinate system sometime between 2000 and 1600 BC. They're the ones who came up with 360 degrees in a revolution. There's no real reason that we know of right now why 360 was chosen. It might be that it's close to the number of days in a year, but not even the Babylonians thought that that was exactly 360. It could be that 360 has many factors, and so it's easy to divide it up into equal parts, different numbers of equal parts, such as 2, 4, 45. It may be related to the fact that 360 is 6 copies of 60, and we could inscribe a regular hexagon inside a circle where the radius is equal to the side length. And given the Babylonians' affinity for the number 60, that might be the reason why. The ancient Greeks also worked with trigonometry, and Hipparchus prepared the first tables of chord lengths, so lists of angle measures and chord lengths. Ptolemy wrote a comprehensive treatise of Greek astronomy up to the point when he lived in the 2nd century AD. And Islamic scholars refer to this book as the Almagest, which is a translation meaning the greatest. Ptolemy's tables of chord lengths were really the precursors to signs, and tables like these were essential for trigonometry until handheld calculators came around in the 70s and 80s. Indian and Arabic mathematicians further developed tables for chords, sines, and other function lengths. They also derived the law of sines and the law of cosines. And what's interesting is spherical trigonometry was developed before plane trigonometry, the right triangle trigonometry that you might have used in middle and high school. And all of the work that the Indian and Arabic mathematicians were doing was generally unknown in the medieval Europe at that time. On the European continent in 1595, Pitiscus, a mathematician, introduced the word trigonometry. Trigonometric formulas existed at that time, but it was very difficult to communicate these to other people because algebraic language had really not been developed yet. But once the algebraic language came about, and also ideas of functions, more trigonometric formulas were developed. And just as an example, here's what some early mathematical language looked like. The first one, xq in E3 EC equator xq in B. You might notice that, or suppose that there's an equals in there somewhere, and there is. X squared times 3e, so that q, I think referring to quadratic, so we're getting a squared, and 3 being 3e, and cubed on the e cubed being this lowercase c. Down below we have something that's actually a polynomial. N to the 7th power minus 7n to the 5th plus 14n cubed minus 7n. What's interesting is n only shows up on the last term in that older style, and q's again meaning probably 2nd power and c's meaning 3rd power, and so we add those together, 2 plus 2 plus 3 giving us 7, 2 plus 3 giving us 5. Another application of trigonometry has to do with shadows and measuring those and being able to tell time based on the length of a shadow. You may know that as the day goes by, your shadow changes lengths. It may get shorter as we get closer to the middle of the day, and then as we go to later on in the day, it even starts to get longer. That object used for casting shadows, the general word is called gnomon. It could have been a stick or a knife or a pole. You might use a pencil or a ruler or your notebook to cast shadows, but it's just another name for the thing that makes a shadow. And YouTube has several videos that are interesting use of time-lapse photography to show an idea of how people got inspired to study trigonometry. One is on motions of stars and planets, and another topic is on the lengths of shadows. And I think it's a good idea to look at those so you can see what, how these things move and how it might be interesting to describe them mathematically.